Welcome to Penrose Learning, where we make understanding easy.
You begin by ensuring your simulator has gates, adders, multiplexers, and flip-flops. This matters because missing parts force workarounds. Next, choose the calculator's scope. 4-bit binary add/subtract is fastest to prototype, while BCD or multifunction needs converters and more control logic. Once decided, sketch a block diagram. Inputs, ALU, registers, control unit, and display driver. Make sure to label bit widths and control signals. That clarity prevents mismatched buses and saves debugging time as you start wiring components. Now you implement the core. Assemble a 4-bit adder with XOR for subtraction, include carry chain and overflow flags so results remain reliable. Once done, add registers with load/enable lines to hold operands and result. Make sure clock edges are consistent to avoid race conditions. Then wire a simple control unit, opcode decoder feeding multiplexers and control signals, or a small state machine for multi-step operations. As you connect buses, use consistent bit labels and test each module independently before full integration. To finish, implement input and output, keypad scanning or switches for entry, and a 7-segment or digital display driver for results. Ensure proper debouncing and binary-to-display conversion. Then run unit tests. Start with single-bit cases, exercise carry and overflow, and include edge cases like max values and sign changes. If something fails, inspect timing and look for bus contention or miswired enable lines. Make sure control signals sequence cleanly, and add small delays or registers to break combinational loops if necessary.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.